Hi guys! So before you can learn to graph a sinusoidal graph, you're going to have to know a few words. First, let's start off with the sinusoidal axis. That is the max plus the min divided by 2, which is also the middle of the max and the min. The amplitude is the distance from the middle to the max, or the middle to the min. The max is the highest point on the y-axis, and the min is the lowest point on the y-axis. Lambda, also known as this line right there,
Mrs. T, could you contact the office,
is
please?
a wavelength. In this right here, y equals sine x, lambda is 360 degrees because by default it's 360. Over here, we have your period. That's the number that you divide 360 by to find your lambda. In this one, there's no number there, therefore 360 remains lambda. Over here, we have our phase shift. That's just saying that it doesn't always start at 0. 0 would be right here at the center point of the graph if it were to continue that way and that way. And sometimes time starts at 20, or a minute, or an hour. It doesn't always start at 0, so that would be shown right here, C. And D, that's just your sinusoidal axis, which we learned right there.
Okay, so the question says a Ferris wheel loads 2 meters above the ground. So I'm just going to do like a little drawing here to show you. So it says it starts 2 meters above the ground, so you automatically know that the Ferris wheel is 2 meters above the ground. It takes riders to a maximum height of 20 meters, so that's basically telling you the maximum height is 20 meters. Okay. The wheel turns at a constant rate and travels from a minimum height to the maximum height in 9 seconds. So that's just basically telling you that it takes 9 seconds to go halfway around the Ferris wheel, which basically means the other side takes 9 seconds as well, because it says it travels at a constant rate. So basically, our lambda would be 18 because it takes 18 seconds to go around the Ferris wheel. Assume a rider boards at the 2 meter height and consider this to be time 0. So right here, time equals 0. Okay. So basically, we're just going to fill this thing out to help us graph a little better. So the maximum, it tells you it's 20. The minimum is 2. The sinusoidal axis, like Sarah told you over there, is the max plus the min divided by 2. So 20 plus 2 equals 22 divided by 2 is 11. Okay, whoops. So the sinusoidal axis would be 11. And the amplitude is going to be 9. Okay, so let's graph this. So the max is 20. The minimum is 2. The sinusoidal axis is right in the middle, which is 11. And like we said, lambda is 18. So half of lambda is going to be 9. And a quarter of lambda is going to be half of 9, which is 4.5. So we're just going to put this on the graph. So 4.5, and another 4.5 is 9. And another 4.5 is 13.5. And another one is 18. Because it takes 18 seconds to go around the Ferris wheel. So our first point, since it's a sine graph, so it starts at the middle, which I'm probably going to need to add that. So the mid to the max, the mid to the min, to the mid. Kind of getting in the way, but whatever. Okay, so we know that it's going to start at the middle, and the middle is 11. The max is 20. The middle is 11. The minimum is 2. And the middle is 11. So basically, just using these points, we're going to start at the middle, which is 11. The max, whoops, okay. Okay, the max goes up here at 20. At 9, it goes back to the middle. 13.5, it goes down to the min. And at 18, it goes back to the mid. So basically, when you draw this out, it looks like this, which that is what a sine graph should look like. Okay, so Sarah's gonna take you over the question. I already still it.
Okay. So to start with, we are going to need an equation to work with, because you cannot logically graph something and not have an equation for it. So we're going to start out here with the amplitude, which is the distance from the middle to the max. The distance from 11 to 20, it would be 9. So we're going to start our equation with y, or in this case, it would be height versus time. So we'll go h equals 9. And then we're going to have our sine, because this is clearly a sine graph, because it starts at the middle. And then we have to put our period. Now we know that our lambda is 18. So in order to find the period, we have to divide 360 by 18. And that gives us 4.5. Just kidding, that gives us 20. So we're going to put 20 here. And then in our bracket, we're going to put our time. So that's t. And we have 0 phase shift because it starts at 0. So we're not going to put a number there. And then we have our 11 at the end, because that is the sinusoidal axis. And that is our equation. Now, question 1. Discuss and explain in a clear, concise manner why the graph of height versus time is not linear. Well, a linear graph moves by a constant amount. It's not always 1 by 1, but it's always the same amount. You have 1 here, goes over 1, then goes over 1, and it goes up 2. It's always at the same amount. This distance from here to this point is always the same. This is not linear because it does not go by a constant amount. A Ferris wheel turns round. Our height always varies. It doesn't keep going up like it would in a linear graph. In this one, we go up to the top, and then all of a sudden we're coming back down, and then we're going up again. So we cannot logically have a straight line. Question number 2. Give the 2 times between 18 seconds and 36 seconds that the rider exactly 16 meters above ground. Okay, well that's simple since we know our equation. All we have to do is fill in our equation with numbers. So they want to find out when it's 16 meters above the ground, so height, we would put 16 equals 9 sine 20 t plus 11. Now, the first thing we're going to do is we're going to move our 11 over here. So we have 5 equals 9 sine 20 t plus, just kidding, we moved our 11 over. So the next thing we're going to do is we're going to get rid of that 9. We're going to divide 5 by 9, which gives us 0.556. We're slowly stripping stuff away from this. Next, we're going to get rid of our sign. In order to get rid of sign, we have to take the opposite, which is sine to the negative 1. So this is going to give us the degrees. So this is telling us that 0.556 is in fact 33.5 25.75 degrees. Next, what do you think we have to do? That's right, we have to get rid of the 20. So we're going to divide this by 20, and we're left with 1.69 equals t. So that doesn't sound right, considering they want the two times between 18 seconds and 36 seconds. So what this is telling us, this is the first time that they're hitting at the time of 16, or at the height of 16 meters, which is right there. So what we're going to have to do to find the first one is we're going to add lambda, which is 18. So if we have 1.69 plus 18, that comes out to 19.69 seconds. And that would be the first time that they reach a height of 16 meters. Now the next one's going to be a little bit harder, because we're not going in from this side, we're going in from this side, from this middle, instead of this one. We're going to have to subtract 1.69 from 9, which gives us 7.31. And then we're going to have to add lambda to that. And that gives us 25 point, that's a funny looking 5. 25.31. So now our 2 points between 18 and 36 that we reach a height of 16 meters are 16.69 and 25.31 seconds. And that's all today, guys. Hopefully we'll see you again soon.